Hello friends, today we will solve a problem on torsion. So this problem is from Pune University paper. So it was there in the paper in May 2005 as well as in May 2012 paper. The problem was for 10 marks. So let's try to go through the problem. A solid shield shaft. So what is the given data? I will write down the given data first. Okay. So for this problem, a solid steel shaft is given and it is subjected to torque of. So torque is given, it is 45 kilonewton meter and angle of twist is 0.5 degree per meter length of shaft. So angle of twist is also given. So it is theta equal to 0.5 degree per meter length of shaft. So it is given in terms of per meter length of shaft. And shear stress, that is tau, should not exceed, so it should be less than or equal to 90 Newton per mm square. So these are the given data. Now what is the first thing that we have to find it out? We have to find out the diameter of shaft. So first of all, we will write down the formula which we are going to use. We are going to use the torsion formula for this kind of problems. So in torsion formula, what is the formula? T by J equal to g theta by L equal to tau by R. So we have already discussed what is strength criteria and what is rigidity criteria. Okay. So limiting condition for strength criteria as well as rigidity criteria is given to us and we need to calculate the diameter. So this is a conventional problem. So for strength criteria, we will go by the strain terms. So tau is the strength term related to strength. So tau is given to us. So in this problem, the maximum limiting value of 90 Newton per mm square will be the maximum stress. So shear stress is given to us. R can be written in terms of diameter. So diameter d by 2. Okay. So radius will be equal to d by 2. Here we need to calculate the diameter. As discussed earlier, we need to calculate the diameter. Okay, now T is given to us and that is 45 kilonewton meter. Okay, so it will be 45 into 10 cube Newton meter and then 45 into 10 to the power 6 Newton millimeter. Is it okay? T is given to us, tau is also given to us. Now, what is J? J is polar moment of inertia. For a solid circular shaft, it is pi by 32 into d to the power 4. If we substitute all this to this formula, that is for strength criteria, it will be 45 into 10 to the power 6 Newton millimeter divided by J will be pi by 32 for a solid circular shaft. It will be pi by 32 into d to the power 4. R will be equal to d by 2 and tau will be 90 Newton per mm square. All things are in Newton and mm. So if we solve this equation, we will get the diameter and that diameter will be in terms of mm. Okay. So please try to calculate this answer. Even I will try to calculate the same answer. So 45, so rough calculations will be here. 45, 1, this will be 2. So d cube. So this will be 10 to the power 6 into 32 divided by 2 pi. This 2 will also go upward, so this will be 4 pi and will be equal to dq. Okay, so this will be, let me solve this problem. 10 to the power 6 into 32 divided by 4 divided by pi, so it will be equal to 136.56 mm. Now, as per the rigidity criteria, the terms which we will use is T by J equal to G theta by L. Now, in this formula, T is given to us. T is again 45 kilonewton meter, and it will be substituted as 45 into 10 to the power 6 Newton millimeter. J again will be pi by 32 into d to the power 4. G in this problem is given as 80 GPa. So we will convert this 80 GPa into Newton per mm square. So it will be 80 into 10 cube Newton per mm square. What is G? G is shear modulus. Next, theta by L. Now, theta is angle of twist, and in the problem statement, it has been given theta per meter length. So, theta by L is given to us, and it is 0.5 degree per meter length. Okay. Now, this 0.5 degree need to be converted. So, for a 1 meter of length, it will angle of twist will be 0.5 degree. Okay, so now here 0.5 degree need to be converted into radian. So to convert it into radian, we will multiply this 0.5 by pi by 180. So it will be 8.726 into 10 to the power minus 3 radians. Okay, so now you will get this theta in terms of 8.726 into 10 to the power minus 3 radians. So we have converted degree into radians. Now if we substitute all these terms back to the equation, T will be 45 into 10 to the power 6 Newton millimeter. Okay. J will be pi by 32 into d to the power 4. L will be 1. Theta will be 8.726 into 10 to the power minus 3 radians. G will be 80 into 10 cube. So if you try to solve this problem, you will get to know the diameter will be equal to 160.076 mm. Okay, so this will be small. So diameter by strength criteria is 136.56 mm. Diameter by rigidity criteria will be 160.076 mm. Is it okay? Now, out of these two diameter, we need to select a single diameter which will satisfy both the criteria. So, whichever is larger out of these two, maximum of D will be maximum of D strength, D rigidity. So, whichever is maximum, that diameter we will choose. So, it will be 160.076 mm. So the final diameter that we will choose will be 160.076 mm. Now, once the diameter has been finalized, means first part of the problem is over. Okay. Now, second part, final maximum diameter, sorry, final maximum shear stress and angle of twist for diameter of shaft is selected. So what we have to do, by taking this diameter into account, we have to do the inverse calculation to calculate to find out the shear stress and theta again. So see here the diameter for rigidity criteria has been selected. Okay, so even if you go for inverse calculation, For rigidity criteria, what will be the formula? The formula will be T by J equal to G theta by L. If you substitute J diameter equal to 160.076, if you substitute T, L and J as it is with this diameter, so G also, okay. So whatever theta you will get, this theta will be same as that of G1, okay. So there is no need to calculate theta again. So this part of the question is invalid, or otherwise you can always write theta will be equal to theta will be equal to 0.5 degree only, okay. So this part of the question will be already known to us, so there is no need to calculate it again, okay. Now second part, final maximum shear stress. Final maximum shear stress can be calculated, okay. So it can be calculated by using the strength criteria, T by J equal to tau by R. Now in this case, T will be 45 into 10 to the power 6 Newton millimeter. J, as it is pi by 32 into d to the power 4. Now we will substitute the new diameter. So it will be 160.076 to the power 4. Okay. R will be equal to d by 2. So it will be again 160 into 0.076 divided by 2. Is it okay? And now you can always calculate what will be tau value. So here you should get tau equal to 55.873 Newton per mm square, which will be less than the which will be less than the 90 Newton per mm square. So as it is less than 90 Newton per mm square, this value will always be accepted. So tau corresponding to a diameter which we have calculated will be 55.873 Newton per mm square. So corresponding to diameter equal to 160.076. So this is the second part of the, or this is the answer of second part of the question. Okay. The next part, find the shear stress in the shaft and take G equal to 80 GPa. So G is known to us, shear stress is known to us. So you can always calculate what will be shear strain value. So this question is very simple now. So you can solve it on your own. So what we have to do, G is given to us. We know one thing, shear stress upon shear strain will be equal to shear modulus G. G is 80 into 10 cube Newton per mm square. Shear stress tau is equal to 55.873 Newton per mm square. Okay. So the remaining part, shear strength, can be easily calculated by using this equation. Equation A. So here you should get shear strength equal to, so I am calculating it for you. 1431.81. What will be the unit of shear strain? There will not be any unit. Okay. So that's it from my side. Thank you.